Hey guys, this is lecture video 3 of CSE2000Q2S Computer Science 2, taught by Lawrence Orijuela, and my name is Lawrence Orijuela. I hope everyone is staying safe out there, and without any further ado, let's get started. So, now before we get into the lecture material, it just came to me that a couple issues came to mind in the progression of me teaching this course. So I've received emails from a few students actually. So for those of you who can't download Visual Studio 2019, in other words, for those of you who own a Mac, that's perfectly fine. You can use any IDE you want, just as long as you can still send the screenshots and the CPP files to me. I even mentioned this in the syllabus, like any IDE is fine. I believe most of those who are using Mac are using Xcode to do their activities. That is perfectly fine. It makes no difference to me in the grading, just so long as I can get these. Okay, so you don't have to worry that you're not using the same IDE as me. I think the only issue here is that you're not gonna follow like the instructions exactly, but that's perfectly fine. You know, if you're learning something from this, that's all that matters. You know, C++ is C++ is C++. So now that that's out of the way, the other thing I wish to address is there are quite a lot of students who added this class late into the semester. And for those of you who did, you can still turn in Activity 1 and Activity 2 without it being late, because I know that you need some time in order to get adjusted to this class and turn things into me. In fact, I even sent an email to all the students who added late, telling them what they need to do in order to get up to speed. Now, those are probably the two only issues that I came across. But if there are any other issues or concerns with this course, please get in contact with me as quickly as you can, and don't hesitate. Okay, I like to think that I'm a reasonable person. You know, I'm a student just like you. I know how hard school can be, and I like to think that, you know, I'm a reasonable person. Okay, so yeah, if there's any concerns or anything, please get a hold of me. My email is on the syllabus. Okay. Now, one other thing. So I wanted to talk about Discord again, because I do know that some of you students who are watching this, you just added late into the semester. So in case you didn't know, we have a Discord channel for the class. And it's not really a Discord channel for the class. It's actually a Discord channel for the entirety of the computer science classes for CSUSB. So this Discord channel is run by CSE students for CSE students. And there are channels for pretty much every class in here where we talk about lecture material, and we help each other out, and everyone's a big community here. I highly recommend that all of my students join this Discord channel, because this Discord channel helped me out many times. And our channel is right here in CSE2000Q2S. Not many people are on it yet, but I still make announcements anyways for those who are on it. But if you wish to be added to this Discord channel, please shoot me an email and I will go ahead and add you, because it's extremely helpful, and I can't recommend it enough. Okay? So now that that's out of the way, we can get started. So we're going to continue going down the line. We covered this and this. Today is September 11th, and today we're going to be talking about user-defined functions and your activity is going to be due next week, and your activity 2 from last week is going to be due midnight tonight. And I already discussed lab 1 in the previous lecture video, but if need be, we can talk about it again. So now, needless to say, I'm actually quite happy that we refinished review part 1 and part 2, because now we can get into the nitty-gritty of C++, the parts of C++ that I personally like, and user-defined functions. Like, when I was building this course structure, I really had to think about the order in which I wanted to teach this material, and I just chose user-defined functions first after review, just because I use it so often, especially in upper division courses when I'm coding my projects for my classes. So anyways, let's get into this. So in case you didn't know, a C++ program is a collection of functions. Up until now, all of our programs only had one function. And you can guess what it is, right? It's the main function, see? Int main, where we code everything. Yeah, that's the main function in which we run our C++ program, okay? Now, although it is useful to have one function for small programs, in large programs, it isn't practical to have all your code in one function. If you perform the same process multiple times, it is good programming practice to write a user-defined function for it. Now, let's move on. Okay, so we're gonna started with the lecture activity. So write a user-defined function that prints hello world. Okay, so imagine for some reason you want to print hello world a bunch of times. Now, even though you could just see out hello world each time, one thing that you could do is write a user-defined function for it. Now, I think the best way for you to learn how to write user-defined functions is if you just watch me make one first, and then we pick up from there. So I'm going to click next. I want to save this over let's call you 3. Create. Okay, so I'm going to go to source files, add new item. I'm going to say main.cpp add let me so you can see it better. IOStream using int main. Okay, so imagine you're outing hello world a bunch of times. Okay, this is like the simplest kind of program that you can come up with. Just a program that outs hello world. Now, and I thought this was a good start to teach you user-defined functions, because if you wanted to print this a bunch of times, I can do this in the form of a user-defined function. So I'm going to say, after all of this int main, I'm going to write a new function on the bottom, and I'm going to call it void print hello world. That's what I'm going to call it, okay? And it's going to have squiggly brackets as usual, like any other function in our program, okay? So in this function, I'm gonna say cout hello world. Like that. And one other thing that I need to do is I have to take this, the name of the function, and I have to put this right between my using namespace standard and my int main. And I have to put a semicolon there. Now, you might be wondering what's all of this. What's the point of all this? Like, void here. What does that mean? Here's the name of my function. Oh, and why do I have to put this over here? Well, just do it for now. Everything will make sense. But now that I have this user-defined function written, I can get rid of this hello world, and I can just say, I'm gonna just call my function instead. So I'm gonna say print hello world. And as always, if you call a function, you have to have parentheses after it. So let's run this and see what happens. So it prints hello world just the same, right? Oh, let me... Now, the only difference between this and just couting hello world is that we turned it in the form of a function. So if I were to copy this function a bunch of times, it would print hello world this many times, okay? Now, you probably want to see how this looks when we're debugging. So I'm gonna put a breakpoint here. So I'm gonna run this again. So when the pointer reaches this line at number 9, we are calling this user-defined function. So if I click step, the pointer automatically jumps to the definition where print hello world is located. So it'll do this code and then return. Okay, so if I step, it'll do the code that's in this function and then return to where it was before. How cool is that? Okay, and it'll do it again and again and again. Now this is what I'm talking about when I say that having one int main function for a C++ program, that works very well for simple programs. But imagine imagine one day you're working for this big software company, and it just so happens that with this program you're writing, you're repeating the same code over and over again. Now, here we're just printing hello world. That's not too complicated, okay? But imagine you're writing a function that has thousands of lines of code, and then you're going to have to write that every time you have to use it, okay? Now, would you want to write thousands of lines of code each time you wanted to do a thing? Or would you rather create a user-defined function that does it and then just call the function every time you use it, okay? User-defined functions, they make C++ programs, they make complicated C++ programs easier to write, and you should know when to use it whenever you feel it's appropriate to. But the key thing to take away here is that you know how to write a user-defined function. Now, I did write this, and I put this here, but you don't know what this void means, and you don't know why this is here. I'm going to get into that in a little bit. Okay? But we just did part A. And you know what? I probably should, here's what I'm going to do. We're going to do the same thing we did before and break this up into sections. So I'll say cout parts A. And it'd be nice to have some space. Well, I don't need that much space. This endl here already gives us space. Okay. So moving forward. Okay, so this is what I want to talk about next. So over here is the exact same print hello world function that we wrote before. Now, so a user-defined function has two parts. One is the function definition, which is here, and the other one is the function prototype, which is here. Now, the definition for a function is exactly what it is. It's the C++ code that defines the function that we're going to perform. Now, you might be wondering what's the purpose of the function prototype. Now, the purpose of the function prototype is, if you recall before, like, I'm going to put a breakpoint there. So, the C++ compiler runs linearly, okay? So, it steps through lines of code, like, starting from line 1, then 2, then moving forward, okay? Now, the reason why we have to have this here is because the compiler needs to know that this user-defined function exists before the compiler can use it. As a matter of fact, if I stop debugging right now, and if I actually decided to comment the prototype out, and if I ran it, it'll crash when it reaches line 10 because it won't know what to do. So if I did it, yep, it crashed. No, I don't want to run the last build. Okay, so the reason why we need to have this here is because so when the compiler steps through line by line of code, when it reaches line 5, it'll see, oh, print hello world is a user-defined function. I'll remember that the next time this function is called. And so if we didn't have this here, and by the time that the compiler gets to line 10, it's going to say, oh, print hello world. I don't know what that means. I'm going to just stop working here because I don't know what to do. That's the purpose of a function prototype, okay? So minimize that. Let's continue. So moving forward, so the function prototype is just the first line of the definition of the user-defined function. So the function definition has its own parts too. So the syntax is written right here in this gray box. So we have the data type, the function name, which can be anything, and then parentheses. Inside of this parentheses, we're going to have a parameter list, okay? And then inside of the function, we have statements, okay? So data type of item returned. So there are two types of user-defined functions. Functions that return data and functions that don't return data. If a function returns data, like say in the form of an int or a string, then the data type of the function has to be of that type, like int or string or double or char. However, if that function doesn't return data, we indicate that by using the keyword void. So take for instance our print hello world function. It's not returning a data type. It's just performing some tasks like couting hello world. Okay? That's not returning anything. You could argue that it's returning a string hello world, but actually it's not really. It's just like for functions that return objects, like the object that's returned is the object that's returned, okay? Anything like couts or anything else, that's just like something that's done on the side, you know? Maybe it'll make more sense when we get into it more. So one thing you might notice is that our print hello world function, see these parentheses here? It actually didn't take any parameters. As you can see, the parameter list can be empty. So the purpose of parameters. Some functions will need information, like a variable or variables, in order for them to perform what they're supposed to do. And now I actually have the next two parts of the lecture activity to demonstrate this. So so both of these are going to have to require some data to be inputted through the parameter list so that the function definition can process it and do what we're supposed to do, okay? So lecture activity 3 part B, write a user-defined function called printOs that accepts an int variable called numOs and then prints the character O equal to the number of numOs. Okay, let's just do this. So it's good programming practice to have your user-defined functions in the same order as your prototype. So I'm going to write this new user-defined function here, okay? Now, because we're just outputting characters, but we're not returning some sort of data, we're going to use the keyword void again. Print Os. Now, what's very important is that it accepts an int variable called numOs, okay? So it's going to accept a variable called numOs, and it's going to be of type int, okay? I have my squiggly brackets here. So we want to print O's equal to whatever value is passed into this variable. So I'm going to need a for loop for that. So I'm going to say for int I equals 0. So we're going to start at 0. This loop will continue until I is no longer less than this variable numOs. And then every time we iterate, we'll go we will increment I. Okay. So I guess we're gonna cout the character O. Right. Now we wouldn't put an end L here unless we really wanted to end the line, but I don't think I want to do that. I think that's kind of wasting space. Okay, so the last thing I need to do is take my function prototype and stick it on the very top. So I'm going to copy this, copy, and paste it right here. Okay. Now, one thing that's very important about function prototypes is that for the function prototype, you don't need to put the name of the parameter that you're passing. You just have to have the data types. So I'm going to delete this numOs here and just say int. So print O is a user-defined function that takes an int. Okay? Now we can test if it works or not by saying cout. We're going to call this part B. And I'm going to call it print O's. Oh, and print O's. Now, I need to have parentheses here, and I have to have an int value inside of the parentheses because that's the data that's required to perform this task. So I could say 3, and it should output 3 O's if I ran it. And it does, okay? Let's see out and line here. So there's some space. Now I could do this again for another int variable if I wanted to. Like, I don't know, say 20. So when the pointer reaches here, it'll jump here. Num O's will be equal to 20, and it'll output 20 O's, okay? So if I ran it... Oh, my bad. One thing that I should have done probably was put a cout end line here. So that way you can see it. So it'll end a line when the process is done. So this is 3 O's, this is 20 O's. That's perfect, okay? Now, one thing that you might be wondering is, am I allowed to do this? Can I say int a is equal to 7? And then can I print O's int a? Am I allowed to do this? The answer is yes, because int a is of type int, and print O's accepts a variable of type int. So when I do this, because int a equals 7, this will output 7 O's, okay? 1, 2, 3, 4, 5, 6, 7. Yep. It does exactly what we wanted it to do, okay? Now, so that's part B. I can demonstrate this further using part C. So, write another user-defined function called print cars that accepts a car named copy car. And an int named numCars. Have it cout copy car as many times equal to the number of numCars. Okay, so this user-defined function is a little bit different from the one we made in part B in the respect that it accepts 2 variables instead of just 1. Okay, we need to pass a car variable and an int variable, and that's not hard at all. In fact, I'll show it to you right now. So I think we're gonna cout part C. What did I call it? Print cars. Okay. Print cars. So I'm gonna have to scroll down here and make a brand new user-defined function. Once again, this is a void because we're not returning anything. Don't worry, eventually we are gonna make user-defined functions that return stuff. So I'm gonna say void I'm sorry, I forgot what it was again. Print cars. Okay. Print cars. So it's going to take a car called copy car, copy car, and it's gonna take an int named numCars. So int numCars. Okay. So the structure for the definition is going to be very similar to this. So I'm going to say for I equals 0, I is less than num cars, I plus plus. Now, instead of couting O, we cout whatever value is stored in copy car. So I'm going to say copy car. Like that. And outside the for loop, I'm going to end the line. Okay. Lastly, I need the function prototype, which I'm going to have to stick at the top. So copy this, put it here, add a semicolon, delete these variable names. So this is a user-defined function that accepts two variables. The first variable must be a car, or char, however you want to pronounce it. And then the second variable has to be of type int, see? So I'm going to call that function here. So I'm going to say print cars. So for the first one, as always, cars have to be surrounded by single quotes. So what's the first character that I want to put? I don't know. Let's put A, I guess. And we want to output this, I don't know, 4 times. And this works because the first variable is of type car, and the second variable is of type int. So if I did this, oh, actually, let's, so we have some room. So I'm going to run this, and it should output A 4 times, and surely enough it does. Now, you might be wondering, can I do this? Do the exact same thing, but I have the A and the 4 switched around, like 4 and then A, like that? The answer is no, because 4 is of type int, and int is not a car, and A is of type car, and car is not an int. So the order in which you input these variables matters a lot. In fact, if I ran this line of code, it would actually crash because 4 is being passed to a car and A is being passed to an int. If you want to see it, I can show you. Yeah, it has no idea what to do because these aren't the same. So I'm actually going to get rid of this. But now you know how to write user-defined functions that have parameters passed to them, okay? So let's see what's next. Let's, okay. So that's not too hard so far, I hope. So if the user-defined function needs to accept parameters, like data, it's inputted through the parameters list. So we wrote user-defined functions before in which the parameter list is empty. Those are for functions that don't need variables to do the jobs. And then we wrote user-defined functions that do take variables. Now, this is very important. This is going to lead up to that void keyword that I'm talking about. However, if the user-defined function then needs to output or return data, the data type of the function needs to match it. If the function doesn't return anything, like say it performs its function and that's it, just use void as its data type. So for instance, if the function returns a string, this data type here has to be of type string. If the function returns an int, the data type has to be of type int, and so on. And I can actually demonstrate that by doing the next part of the activity. There's actually one thing that I forgot. So this is a very important note. This is the main difference between a function that's a void and a function that returns a data type. So void functions are simply functions. They can stand alone as lines of code. However, data type functions, because they return a value, you would have to treat them as you would another variable. You would have to cout them in order to see what they return. But this will make more sense when I actually show this to you. So, lecture activity part 3. okay? Write a user-defined function called hyphenate strings that accepts two strings called string A and string B. It returns a string, I put that in bold, that is string A concatenated with a hyphen concatenated with string B. Okay, that sounds very easy. Let's actually do that. So it seems to me we're going to add another user-defined function here. So this is our fourth user-defined function we're writing, okay? Now, this is very important. This returns a string, so data type has to be of type string, okay? So instead of writing void, I'm going to say string, like that. And I'm going to call it hyphenate strs. It's gonna take a string called string A and another string called string B. String B. Like that. Now I think you kind of learned a little bit about strings in CSE2000, but if you wanted to concatenate them, you would use the plus sign. So I would say return. I would use the return variable because we're returning something. Now the object we're returning is going to be string A plus hyphen plus string B. Well, actually, I wonder if I'm allowed to have this compound statement here. Actually, delete this. I'm gonna do this to Safeway. Here's what I'm gonna do. I'm gonna declare a new string variable called stir, and I'm gonna say string return equals stir A plus quotes hyphen quote stir B. And then I'm going to return. So string return should be equal to string A concatenated with hyphen concatenated with string B. Okay? So the last thing I need to do is copy this, put this over here with my other prototypes, add a semicolon, delete these variable names because we don't need them. So this is a user-defined function that takes two strings and then returns a string. Part D hyphenate strs. So let's say hyphenate strs. The first string we're gonna pass into it is gonna be, I don't know. Let's use the string pen. Okay? And then for the second string, let's say pineapple. So what should happen as a result of this is that it'll take pen and then hyphenate it with apple, okay? However, there's actually one very important thing that I'm missing. Hyphenate strings is not of type void, it's of type string. So in order to see this, we would have to treat this whole thing as if it were a string variable. In other words, if we wanted to see the contents, we would have to see out it. So, and that's what I was saying before. That is the main difference between a void function and a data type function. Okay, So I'm gonna say cout hyphenate strings, and it should, what this should do is take pen and hyphenate it to pineapple. Okay. And it does. See? Pen, pineapple. Okay? Now, I want to add an extra line. So, if you wanted me to demonstrate the hyphenate strings function again, one thing that I could do is copy this line of code, put it here, and then change these strings to say something else. And I don't know. Let's put two different strings. Let's put maybe apple, and for this one, let's put pen again, just because we can. So if I did this, this should say, it should take string apple, hyphenate it to pen, because that's what we defined here. Okay. Oh, my bad. Let's end the line and then see it. So we got pen, pineapple, and then apple, hyphenated to pen. Okay? Now, here's a very important question that we've reached here. Can I pass user-defined functions into user-defined functions? In other words, can I do this? Cout stirs. And then for my two strings, what if I took this, made that the first string, and then I took this and passed this as the second string? Like that. Am I allowed to do this? Like honestly ask yourselves, am I allowed to nest user-defined functions inside of user-defined functions? Think about it. The answer is yes, because hyphenate strings is of type string, so we can return it, we can treat it as though it were a string. And because it accepts a string, we can have two hyphenate string variables pass to a hyphenate strings function, and it will give us a unique string. So if you wanted to see this in action, I'm going to click play again, and we have pen, pineapple, apple, pen. Cool, right? Now that's obviously not a reference to any pop culture anything. I just decided to come up with these four string variables at random. Okay? So I'm glad I got to show that to you. That is how we create user-defined functions that return variables. Oh, my bad. Let me find where I was before. Now, I added these two other parts here simply because I think if we learn how to make user-defined functions, like if we did it enough, it would stick, and you would learn how to make user-defined functions by yourself. So let's do part E together. Write a user-defined function that called isEven that accepts an int called thisInt. It returns a Boolean value. True if even, false if not. Hint, use mod. Okay. So it looks like we're going to make a new user-defined function. I'm going to put it after our hyphenate strings function. So this needs to return a bool. And in case you forgot, a bool is a true or false value. Okay? So isEven. It's going to accept an int called thisInt. So in order to find out if an integer value is even or odd, all we have to do is mod it and then see its remainder. So if this int mod 2, so this will take, oh wait, my bad, is equal to 0. Yeah, okay. So if we took an integer value and mod it by 2, this will give us the remainder if it was divided by 2. So if there's no remainder after dividing by 2, that means it's even. So we're gonna return true when we reach this part. Now this is very important. When we return from a user-defined function, any other code that's not executed will not execute. So I can put return false here if that doesn't happen. So so this is the main reason why I wanted to do this, because this is a property of the return function. So let's say that we passed 18 into this, okay? So 18 modded by 2, obviously this would be true. And then when we return true, when the pointer reaches this line, what would happen is the pointer would return to where the function was called, and this line of code would never execute. Otherwise, if this is false, this line will never execute, and then we'll return false and then return to the statement where this function is called. So I'm gonna demonstrate that over here after I get this prototype, of course. So I'm gonna copy this, put you here, semicolon, delete this variable name, and now see out part E is even. So I can do this for, oh, I have to see out because it's returning something. So I'm gonna say is even. Let's do a number that is even. So I'm gonna say 18. And then let's do it again. Let's use an odd number, 19. Okay. So what should happen as a result of this is that this will return true and this will return false. Let's see it. Oh. So one thing that I forgot to mention is that Boolean values are, when you see out a Boolean value, it'll see out 1 if it's true and then 0 if it's false. My bad. That kind of slipped my mind, but you get the point, right? Well, showing you what a bool returns isn't the point of this part of the activity. The point of this part of the activity is to show you this thing with the return function. That's the main thing, okay? So we're actually almost done here. So the last thing we need to do is write a user-defined function called intGreater that accepts 2 ints and returns an int that is the greater of the 2 values. I think the reason why I added this part is so that I can show you something else you can do with the return. So new user-defined function. This function is going to return an int. Int is greater int a int b So, if int a is greater than int b, we'll return int a. So, if int a is greater than int b, return int a. So what's very important is that when we return the data type of the thing that we're returning has to match the data type of the user-defined function itself. Now, because int a is of type int, we can do this. Now, else, so this would happen if this is true. This will happen if this is not true. So return int b. So if a isn't greater than b, there's only two outcomes. Either a is equal to b or a is less than b. If that's the case, we can just return b. Okay? Copy this. This will be our prototype. Semicolon. Get rid of this data name. So now we can use this function now. So cout part f is greater, like that. Now cout is greater. We need to give it two ints. So I'm going to say 30, 50. Now because 50 is greater, this should output 50. And I'm going to say cout is greater. I'm going to say 1,000 and 100. So this here should output 1,000. Okay? Let's see. Oh, my bad. I need to put end lines. Like that. It's not doing it? Okay. Oh. Let's put an inline here. That's why. Oh, you know what? I'm actually quite happy that I made this mistake. Do you see this cout endl here? This line would never execute in either case, because when we return, the remaining code's never seen. When we return, the remaining code's never seen. So this will actually never happen. So I'm actually kind of glad I made that mistake so that I can share it with you. So that's another thing that you need to know about the returns. Like, if you wanted to see it in action, like, well, first of all, let's test if it works. So we should see 50 and 100, because 50 is greater than 30 and 1,000 is greater than 100, right? Okay. Now, I'm going to put a breakpoint here so you can see what happens. Well, actually, let's put it here. So the pointer is here, okay? Immediately we jump to the definition of is greater. Now because looking at autos, int a is equal to 30 and int b is equal to 50. This means that this should evaluate the true. Oh, my bad, false. So we ignore this, jump to here. When we return b, when we return, the pointer will jump back to the definition and not do anything else. Okay? Same is true here. When we return, this code is never seen. Yeah. That's why. Okay. So, looking back. Oh, that's actually the end of the PowerPoint. So, we're actually finished now. So, in order to get credit for this, you already know what to do. What you need to do is 4 comments on the top. Name, SID, and then do 9/18/2020. Okay, so save that, get a screenshot of this. Oh, I need to remove the breakpoint, my bad. So run this, get a screenshot of this. Get your email open, put the screenshot there, send it to me. CSE2000Q2S, last name, first name, Act 3. And then remember to attach the CPP file. Send. There. Now, I'm actually happy. Like, I know that this is quite a lot. Like, we created six unique user-defined functions in one program. But the reason why I wanted to do so much was because, hint, hint, if you have a question on your midterm that looks very similar to the lecture activities that I put into PowerPoints, like say this, like, if you get a question on your midterm that tells you to write a user-defined function that does something like this, or does something like this, you should be able to do it. Hint, hint. In fact, if I wanted to, I can go to the Blackboard and show you your practice midterm. Because the practice midterm is very similar to the real midterm. I know we're only in week 3, and it's too early to be talking about the midterm, but all of the material that we're covering is building up to everything that you should know, so that you're prepared when you take CSE 2020. Okay, so I'm gonna go to the practice midterm, download that. So, the first question of the practice midterm is very similar to Lab 1, as is question 2. This is something else. But, over here, write a user-defined function that does something and outputs this. Write a user-defined function that does something and outputs this. So, question 4 of your midterm is going to be all about user-defined functions. So, it's very important that you know this. Okay? Now, as always, if you need any help with this course, or you need help with the lab or anything, please don't hesitate to email me, or you could join Discord and then message me there. I'll respond faster if you message me on Discord. But anyways, this is all I have for this week, and I guess I'll see you next week if there's nothing else. Alright, thank you. I'll see you next week.